Good afternoon and welcome to the last AgTech Professional Forum event of 2020. It's been a crazy year and we're glad we've made it this far and we're enjoying this lovely weather. And so I think it's really apropos that we are talking about saltwater intrusion today while we're seeing the after effects of Hurricane Ada coming across our state right now. So I'm glad you could all join us from the nice, warm, and dry confines of your home or office. I wanted to start today with a couple of announcements. We have very few events left this year. We only have one more that I want to make sure everybody's aware of. On November 16th, we have the Animal Health and Nutrition Exchange Group. They will be talking about the vaccine development pathway. And at a time right now when vaccines are needed like tomorrow, it's really ideal that they're going to be talking about how animal models are offering even more key insights into making that happen. We'll hear from Dr. Jonathan Fogel, who's an associate professor of microbiology and immunology over at the Center of Veterinary Medicine at NC State, and also Dr. Jennifer Philby, who's the CEO at Mason Animal Health. So check that out. It's on our calendar on the website, and you can get more information about registration. 2021 is going to be a really exciting year. We have a lot of new ideas that we're really tossing around, and we have one that we're really excited about, and we hope that it's going to pan out. So stay tuned, and hopefully we'll have an announcement to make here by the end of the month. We are looking to expand our reach and connect with other key hubs and stakeholders within our ecosystem. So we hope that starting in January, we'll be able to offer a monthly event that will not only feature RTP, but hopefully other areas from around the country. So at this time, I would like to invite our sponsors to join me on the screen, if you can. This event series is not possible, and I know you hear me talk about them every time we meet, but this is not possible without our sponsors. And our annual sponsors have made all the difference, and most of them have been with us for the 5 years that this event has been in its current format. So I really want to give them a moment to say hello, because we've not been able to see them face to face in 7 months now. So I'd like to first start with Alice Bonnen from Myers Beagle. Welcome.
Hi, well, good afternoon. My name's Alice Bonnen, and I'm an attorney and shareholder with the law firm of Myers Beagle. We are an intellectual property firm with a primary focus on patent law and have a single office in Raleigh near the Crabtree Mall. We have 23 patent professionals covering the full range of technology, including chemistry, biology, mechanical technologies, and electronic and computer technologies. All our clients include universities and corporations of all sizes, as well as startups. Normally, in the good old days, we would have had an opportunity to speak with everyone at the social following the program, but we hope that you'll reach out to us by email or telephone should you need any assistance with protecting your IP. Thank you for joining us today.
Thank you, Alice. I also like to thank Rod Wilson from HPG. Welcome, Rod.
Thank you, Michelle, and good afternoon, everybody. It's a pleasure to continue to sponsor these events with our co-sponsors, and always look forward to these. As Alice said, it's disappointing we haven't been able to do this in person and get to meet people face to face, but at least we've still been able to do it this way. HPG is a full service accounting firm in Raleigh, North Carolina. We're one of the largest in the locally owned and operated firms in the state. I'm a partner and I lead our outsourced accounting group, but we also have full service tax and audit teams as well. So we have a broad life science practice, of which ag tech is a subset, and I lead that ag tech practice in addition to the outsourced accounting team. So happy to connect with anybody via email or phone or Zoom or whatever we can do these days. I'm happy to do so. So don't hesitate to reach out if we can help you with any accounting needs. Thank you.
Rod will even meet you over a game of basketball. Just kidding.
Correct.
I also want to thank Jason Brady from Smith Anderson Law.
Hi there. It's good to see everybody virtually here. Again, echo what everybody else has said, that I miss the opportunity to be there in person and to share some food and drinks with each other, but appreciate the opportunity to be able to host this and help put these conferences on. So I'm a partner with Smith Anderson, and Smith Anderson is the largest business and litigation law firm headquartered in the Research Triangle region. We provide a full range of legal services with a particular focus on representing ag tech companies, such as many of the companies that might be represented in the room tonight. While we are locally rooted here in the Triangle, we are ranked by Chambers Global as one of the top 9 law firms for agribusiness worldwide. We've represented over 50 ag tech companies in 13 states, 7 foreign countries, and our clients range from startups to VC and private equity backed growth companies and beyond that. Recent transaction highlights for the firm include our representation of LO Life Systems in their collaboration with Dole Food Company to help save the Cavendish banana, and Pairwise in its collaboration with Plant Sciences Inc. to transform the berry market in the United States. So thanks for having us this evening.
Thank you, Jason. And I want to thank our newest annual sponsor this year from Global Ag and also iSoftware, Les Thompson.
Hey, everybody. Happy Veterans Day. If we got any veterans online, thank you for your service. I'm Les Thompson with Global Ag. We serve as an outsource for the ag industry for the product development process, from early proof of concept all the way to market. And having been in business for almost 40 years, we've established an experienced internal staff, a board of advisors, as well as an extensive global network of CROs, universities, and industry organizations to help with our client-specific needs. We also leverage our sister company, iAdvantage Software, and its e-study platform to efficiently collect, compile, and report all of the data associated with the development process. And we're looking forward to the forum.
Here. And last but certainly not least, we actually created a new sponsorship level this year because there's the new Launch Labs out of Alexandria Real Estate Equities. And we, of course, wanted them to be able to participate. And we were very much thank you for your sponsorship. So Blake.
Yep. Thank you, Michelle. And a big thanks to the biotech team for continuing to put on these events. I know it's obviously been a challenging year, but it's still great to see everyone virtually as we can. I think many of you know us as Alexandria. We're the largest provider of life science real estate in the Triangle with our recent acquisition of the former GSK campus. But most relevant to this group is our Ag Tech campus located at Cornwallis and Davis. So we're delivering the second half of that campus early next year, which is going to be a multi-tenant office lab greenhouse complex. And we are located our Launch Labs there, which is our incubator platform for early stage companies. And that's now going to be integrated into the overall campus, providing those services across, a spectrum of a 5-person company in Launch Labs up to a 75-person company down the hall. I also do our Ag Tech venture investment activity. And so would love to talk with anyone, of course, about space if you need it, or I can direct you to the real estate team. Or if you're in a fundraising mode, happy to connect on financing. But thank you again, Michelle and the team, for putting these together.
Thank you, Blake. And thank you again to all of our sponsors. Please feel free to reach out to them. And if you need contact information, reach out to me and I'll get you connected to any of our wonderful sponsors. Thank you all. So next, I wanted to touch on a little housekeeping for tonight's forum. We are going to continue to do Q&A down in the Q&A box at the bottom. That you'll notice, not the chat box, the Q&A box. So throughout the program today, please feel free to go and put those in. Today's gonna be a little different because if we have a question that's really relevant to the conversation at hand, we are gonna go ahead and pass those along to our moderator. And if there are any that we need to hold till the end, we will still around 5:15 answer all the remaining questions. So without further ado, I want to welcome my colleague, Paul Ulanch, who has worked diligently more recently in a project on saltwater intrusion, and he can speak much more intelligently about it than I can. So thank you, Paul.
Well, welcome everyone. And before we begin, I want to point out one of our panelists actually it appears on my side that he has my name under his profile, so I am not on the panel. It will be Steve, so
We are trying to fix that.
Make sure Steve's able to join. But I want to welcome everyone. We're pleased for covering this topic. As Michelle mentioned, we've actually spent a lot of time trying to take a deeper dive on this to see if there's any biotechnology solutions or opportunities to leverage here. This is becoming an increasing concern, not just along coastal North Carolina, but it's really a global issue. So to set the stage, North Carolina has 322 miles of ocean coastline, but there's a lot of estuary system. It's the second largest estuary system in the United States. And if you look at the total coastline, it comes at 12,331 miles. So much of this coastline is forested wetlands and agricultural productive lands, and both of which of these are susceptible to excess salt. So we want to, and many of you may have even heard about the ghost forest along the coast. And that's just one example of the damage caused by excess amounts of saltwater intrusion. So the goal today is kind of twofold. It's certainly to bring awareness to what is this problem, what's the broader challenge, but it's also kind of to help rally a lot of the expertise we have in the area around hopefully maybe identifying solutions. It could be broad solutions, could be molecular solutions, and I think you're going to hear from our panel today to cover a lot of these different topics. So in North Carolina, there's a considerable base of expertise on this topic. We have researchers in North Carolina from NC State, Duke, UNC, East Carolina, Noaa, the Nature Conservancy. So we assembled today's panel really provide a broad representation of the issue at hand, and it's going to become apparent when they get introduced. So to kick off today's discussion, I'd like to introduce our moderator, Dr. Kathy Boomer, who's currently the Scientific Program Director with the Foundation for Food and Agricultural Research. Prior to joining FAR, Kathy spent time with the Nature Conservancy and the Chesapeake Research Consortium, somewhat on this very topic. So she's very well aware of the discussion at hand. So Kathy, thank you for joining us today.
Thank you, Paul, and thank you, Michelle, for providing this opportunity to develop or share a more nuanced understanding of how sea level rise and associated changes might influence our coastal systems, and particularly the impact to agriculture. I'm going to start with introductions to the panel members, and then after that, we'll invite each of them to give us a little bit of context to their work and also how their work is relevant to helping us understand the impacts and maybe the opportunities for mitigating those impacts. And then, as Michelle mentioned, we welcome questions throughout, and we'll have plenty of time on the backside to continue the discussion. So the first person I'd like to introduce is Steve McNulty. He's with the NC State and the director of the USDA Southeast Climate Hub. Steve, take it away.
All right, thank you. How's my sound?
Excellent.
Great. Well, thank you. I appreciate the opportunity to be here today. And I either can share my screen. Is that the preferred option, or do you want to use the version I sent? Sharing my screen is probably easier.
Yeah, do we want to, let's go through introductions just to
oh, I'm sorry.
No,
okay.
no. Just to say a bit about where you are, your work.
Absolutely. Yep, my name's Steve McNulty. I have a couple of slides here that I was going to show on where I work, but I'm part of the Southeastern Climate Hub, which is part of the USDA. The hub's been around for about 7 years, and we're located at Research Triangle Park. Our message is to increase resiliency on working lands to climate variability and change through adaptive management.
Excellent. And so Steve really works at the landscape scale and has done a lot of work thinking about sea level rise, climate change impacts up and down the East Coast. Our next panel member works more at the field scale. Dani Wiseman is a postdoc in the Tully Lab at the College of Agricultural and Natural Resources at the University of Maryland. Dani, if you want to say a few more.
Yeah, hi everyone. So it's nice to talk to you today. So I realized that this panel is very focused on saltwater intrusion in North Carolina. So I'll have a lot of the information I'll share is from my experience working on field sites in Maryland, but I think you'll find that a lot of the information is very transferable and applicable actually across the entire region, even though there are some geographic differences. And I'll be sharing a lot of really interesting stuff that me and my colleagues have been working on for the past 5 years on the Lower Eastern Shore of Maryland and the Chesapeake Bay.
Great, thanks, Dani. And then our third panel member really works at the plant or cellular scale, and that's Dr. Rubén Rellán-Álvarez, who is an assistant professor of molecular and structural biochemistry at North Carolina State.
Hi, Kathy, and hi, everyone. Can you hear me? Yeah, so my name is Rubén Rellán-Álvarez. I have worked during my whole career generally in plant responses to abiotic stresses. I have worked in tolerance and stress due to heavy metal contamination, adaptation to low concentrations of nutrients. And related with this theme, I did work during my postdoc developing root imaging methods directed at studying stresses like salinity that are difficult to study in more controlled artificial systems like plates, etc., etc.
Thanks, Rubén. That's great. So I'd like to start with, I'm going to share a few slides. I'm going to share my screen just to provide some context and help see the discussion. And I found a great graphic that the USDA put together. Can everyone see that? Oh.
Looks great. Oh, went away.
Are you seeing the USDA, the importance of agriculture in the U.S. coastal plain, or are you seeing the green
Coastal plain
terrestrial area? This is.
Yep, seeing the importance of agriculture on the U.S. coastal
Yes,
plain.
okay, I was having a hard time telling which screen you were seeing. So this is, I thought, a really interesting graphic that communicates the importance of agriculture, animal versus crop production across the US. And so the redder the color, the more agriculture is related to animal feed and animal production. And the greener the color, the more it's related to food crop production. And the other aspect of this is that the darker the color, the more value in that agriculture. What's really interesting to realize is how important agriculture in North Carolina along the coast and in fact the mid-Atlantic region is to the overall agricultural sector. In fact, the value of animal feed production on the Delmarva and in North Carolina is comparable to the food production that occurs in California, which we often think of as kind of the high value crops in agriculture. So I think this really hits home the importance of thinking about potential impacts from sea level rise on agricultural production in the mid-Atlantic and the mid-eastern seaboard. I also just wanted to point out that animal production does not necessarily mean poultry houses and hog houses. It also is corn production, wheat and soybean production are all a big part of that animal production. So the croplands are an important part of our landscape, as we all know. And then the last slide that I just wanted to share to help set the context here is part of my job. So I'm with the animal with FAR, but I also sit on the Science Technical Advisory Committee for the Chesapeake Bay program. And we've done a lot of work, of course, recently thinking about the impacts of sea level rise and storm surges on the Chesapeake Bay system. And I just like to point out that a lot of this work is focused on the open water areas. And so this middle diagram here is a transect from the northern end of the bay to the southern open mouth, the oceanic bay on the left. Let's look at the bottom panels first. The bottom panel from north to south, so from the Susquehanna to the oceanic areas, in a dry year versus a wet year on the right. So just to point out that a lot of variability in those salinity gradients. But then what we're starting to do is look at how those salinity gradients change in response to sea level rise. And so as you go from top to bottom on these panels, you see the change in the salinity with a 30 centimeter increase of sea level rise, 50 centimeter, 100 centimeter, and 150 centimeter rise in sea level. And in these top four rows, the cooler colors indicate less of a change, and the hotter, redder colors indicate a greater change in those salinity conditions. And so the take-home point here is really to realize that the biggest changes we're seeing are at the fresh water end of that gradient, right? So inland areas. But here's what's really important and relevant to today's conversation is we also know that these changes in salinity will have an impact on all the tributaries feeding into the Chesapeake Bay. And not only that, the rise in sea level, the changes in salinity will affect the surface and groundwater interactions in these coastal lowland areas where agriculture occurs. And so it's really great to have the panel of experts we have today who can help us try and start to understand the changes in the impacts that are poised to occur or even starting to occur in these terrestrial estuarine transition zones. So with that context, I'm excited to pass the ball to Steve, who's going to give us continue on this kind of big picture view of potential impacts from climate change and sea level rise on the East Coast.
Great. Thanks, Kathy. Let's see here. I need to start sharing. And I think I have the ability to do that. Put this one up. Make it big. All right, let's see. Doesn't look like it's taking up the whole screen for some reason. Oh, maybe it's coming up now. There we go. Can you all see that? Southeast Climate Hub?
Yep. Yes, that looks great.
Okay, super. All right, well, thanks again, Kathy, and thanks for, appreciate being here. I'm going to talk a little bit about the big picture. As I mentioned on the introduction, the USDA Southeast Climate Hub, we have a pretty large geographic area that we're responsible for. It is the Southeastern United States. You can see Raleigh in there, but we're responsible from everything from Louisiana and Arkansas and Kentucky and Virginia down to Florida. But the area of coastal sea level rise and coastal storm inundation is probably one of our greatest challenges that we face. And what the hub does is it takes the science and it's designed to convert the science into practical applications for the land manager. So whether you're a forester, a farmer, or a rancher, we're here to increase the resiliency of your working land to not only climate change, but all forms of disturbance. So I'll just give you a little context of the other hubs. We were established originally under the Obama administration, and we've actually fared fairly well under the current administration because we represent one USDA. We have agriculture, USDA Forest Service, ARS, NRCS, a whole bunch of the different agencies are part of the Department of Agriculture, and we work with all of them in our mission. An idea of the type of stuff that we do and related to sea level rise and salinity, we just came out with a user's guide for hurricane recovery and preparedness for the southeastern U.S. The picture is a pine forest landowner's guide, but we actually have 22 of them. And you can see them listed on the right there. These just finished the last one, I think, last Friday. And the idea is to keep these online as a online document until December and let them be vetted. and take comments on them. And then after that, we're going to make hard copies of these documents, and they'll be useful for the practitioners of these types of produce. So that's what we do. And so the work of soil salinity and how we adapt to it and how we mitigate it is part of that same charge that we have as a mission. There's just a couple of slides to show how the yields change for different types of crop species with different levels of salinity. And on the bottom there, I have stages 1 through 4, and I'll talk about those in just a second. But you can see that in most cases, when you get to stage 3 salinity, and this is measured by electrical conductivity of the soils, you lose an awful lot of your productivity. So that's a major challenge for producers if they have some form of salinity in their soil, and by the time you get to stage 4, pretty much everything except for asparagus is non-productive. So these are for vegetable crops.
Steve, I'm sorry.
Yes.
Your slides are not advancing. If you would not mind, if you could put it into presentation mode, and for some reason it's not changing.
Okay, thank you for that. Let me get out of that and okay, can you see it now?
It's still on. Oh, wait. There we go. Can you go into presentation mode maybe so it takes up more of the screen?
I think that's what I was in, unfortunately. I was in the slideshow. Okay. Let me,
And we'll also have a lot of feedback on your end. I think it's kind of staticky. Okay. Thank you.
All right. Okay, is that better?
Yes.
Okay.
Not in
Okay.
presentation.
So just to recap, this is what I talked about as far as the Pine Forest Landowners Guide and the other types of guides we produce. These are for hurricanes and recovery. But in talking about the salinity and what salinity issues are, these are, this should be a screen up there now of crop productivity loss with different stages. Hopefully, yep, I'm getting nodding heads, that's good. And basically what it shows is that there are different yield losses at different stages of salinity. By the time you get to stage 4 salinity, you pretty much have lost all of your crop with the exception of asparagus, which of course is not a major East Coast or coastal crop. Similarly for fruit crop production, it's very similar, except that it actually declines faster. So depending on what crop you have, strawberries are probably the very worst. And that's not a major crop in North Carolina, but there is some. By the time you get to stage 2, there's no productivity. And by the time you get to most of these, there's very little productivity by stage 3. So the idea was, what can we do and how can we better understand what's going on with salinity and how can we help the landowner to better prepare for it? What I have up here now is a figure that we developed to try to better understand how salinity changes across the southern coastal area. And there's really 3 levels that we see for it. One is storm surge, one is sea level rise, and one is the irrigation of saline water. And across the bottom there, and this looks like it got a little bit messed up for some reason on the screen. It looks good on my screen, but not projected. The stages are right below the graphic there, where it says stage 0, 1, 2, 3, 4, and 5. 5 is actually water. So stage 4 is when it becomes non-commercial. This may be an area where you would put your land into NRCS conservation easement. It's no longer commercially viable. And the EC, the electrical conductivity, it shows for each one of these stages to give you a little idea of what that looks like. So stage 1 is fairly sporadic salinity. You may have one storm surge event, and then after that, you could get some freshwater flushing because of rain or irrigation, and you can actually move from stage 1 back to stage 0 and go back to full productivity. Once you get into stage 2, it's reoccurring episodic salinity, so it may be continuous storm surge or king tides or those sorts of events that continuously refresh the saline solution in that soil. By stage 3, it's chronic salinity. This is where you actually have water coming in through the groundwater and creeping up. By stage 4, you're now into a very saline soil, and again, it's not commercially viable. So what we did was we did a review of the existing literature as to what levels of productivity loss there would be at the different stages and what options you would have as far as addressing the different stages of salinity to maximize your productivity. And we just completed this document now, which is called Coastal Salinization and Adaptation Producer's Guide for the Southeastern United States. And it goes into each one of these 5 stages, 4 if you ignore water. So the 4 actual stages. And what it does, it looks at forest, range, and agricultural productivity. I hope to have a website available for this call, but we just finished it last week, and we don't have a confirmed website for it yet. It's still being put through the USDA system. But anyhow, the idea with this is that there are certain mitigation measures that you can do in the early stages of salinization that can reverse it. But once you get to a certain stage, then it's a matter of what crops are best suited for these particular stages of salinity. So we feel that this is a useful, very applied product that can be used across the Southeastern United States, up through the Delaware, that area of Maryland, all of these areas where they have fairly problematic levels of salinity. And then also this could be useful in Louisiana, in the Delta regions where they have some production there and salinity problems as well. So the work we do, again, is very applied. It's very big picture scale. And I'll turn it back to you, Kathy.
Thanks, Steve. Great to start thinking about kind of the transition zones and how they're shifting in response to climate change and sea level rise. I'm going to pass the ball to Dani now, who's going to help us think about the changes within a field, not just with regard to plants, I understand, but also thinking about soil nutrient dynamics.
Yeah, thank you, Kathy. And thanks, Steve, for all that really great information. I think you'll see some overlap in my slides. Let me start sharing my screen here. Oops. All right. Okay, can everyone see that okay? There we go. Okay. So again, I know this, most attendees are probably coming from North Carolina. Maybe we have some people from other places in the region. A lot of the work I've done is focused in the Chesapeake Bay, but a lot of it's very applicable. So a lot of like the numbers and figures I'm going to show are from the Chesapeake Bay region, but I imagine you'd see similar trends in North Carolina. So yeah, just a quick overview. As we know, by let me move this out of the way. By 2100, a lot of areas on the coast are going to be heavily inundated, and that the lower eastern shore of Maryland is a particularly vulnerable hotspot because we have actually land subsidence, so land sinking and the sea levels rising. So these pictures really show what that's going to look like in 80 years or less. We're predicted to have 1 foot of sea level rise by 2050, and you can see huge swaths of the county are gone. And if you look at kind of this key here, you see that these 2 counties I'm showing you are heavily agricultural. So much of that land is going to be agricultural land that's going to be lost. And if you're curious about playing with those sea level rise projections, this Noaa sea level rise viewer, and the URL is here, is a really great link to kind of see how much of the coastline where you're working or living is going to be inundated. Trying to advance my slide. Okay, so as you know, there's a lot of different drivers of sea level rise, so I'll talk about those a little bit. Or saltwater intrusion, so there's the obvious sea level rise. There's storms and tides, so I hear you all are experiencing a hurricane currently in North Carolina, and we're getting the rain, sort of the tail end of that. So these storm events are very important in delivering a large amount of salts all at once to ag land. And these pulses, we're trying to figure out what's the impact these pulses are having on crop yields, on nutrient cycling in soils, on how fast the soil is being salinized. So we're seeing that there's the slow, steady creep of saltwater from groundwater intrusion and maybe high tides, but then you're also getting these big pulses from these major storms. Drought is contributing to saltwater intrusion. So with climate change, the precipitation regimes are changing in different areas. So it can further exacerbate the effects of saltwater intrusion. Also how we manage water. So as you know, as areas become developed or more heavily invested in ag, water is diverted, so fresh water can be diverted from places, allowing salt water to move in. And also the connectivity of the area. So on the East Coast, we have an extensive network of ditches that were carved into the land a long time ago. And a lot of these ditches were intended to drain excess fresh water off lands. But as sea level rises and the land subsides, we're actually now seeing that a lot of these ditches are connecting up to tidal creeks and marshes and becoming actually conduits to help saltwater move farther onto fields. So what are the effects of all of this? So I know Steve talked a little bit about coastal forest loss and ghost forests. So I have some good pictures to show you from examples. And I'm sure you've seen those if you've seen like a stand of dead trees on the coast that look like they're completely debarked. You can see where that salt front's moving in. Species invasion. So things like Phragmites australis, which is a salt tolerant reed, can move onto agricultural lands. Of course, yield declines, eutrophication. So there's an interesting feedback between the ionic constituents that are in sea salt and nutrients locked into soils from decades of fertilizer use. And there's a huge amount of literature now that's showing that actually that interaction can cause pulses of phosphorus and nitrogen into waterways. And of course, we're also seeing marsh migration. So we're seeing marshes move upland into agricultural areas. So I just wanted to show you, so we've taken a lot of cool drone footage of the sites that we work on. So this is just an example of one of these sites in Somerset County on the Lower Eastern Shore in Maryland. So you can kind of see in this picture our plots where we're testing out these different salt tolerant crops. And if you see these bare patches on the landscape, that's where the salt front has moved in so heavily that crops are having a really hard time growing. And if you look just behind the little stand of trees here, you can see this tidal creek. And this creek is usually brackish, so it ranges from around 5 to 15 parts per thousand salinity. So you can see how close these ag fields are to that source of salt water. So I'm going to show you some interesting work that some colleagues of mine at George Washington University did, Dr. Kern-Gadan and Man Key. They basically looked at National Agricultural Imagery Program data from 2009 and 2017 to try to determine by this process, and don't worry about the details of this here, this is just to show you how they did it, but they wanted to see how much ag land had actually converted to marsh. So they applied this methodology here and sort of used this accuracy assessment to make sure it was accurate. These are the numbers they came up with. So you can see the these different categories here. So that's this first one here, for example, is ag land to marsh. So the largest category of land change or land type change was actually agricultural land converting to marshland. And they found that within the last decade in this one county in Somerset County, 860 acres of coastal farmland had become marsh. And actually in the same time period, 500 acres of coastal forest land had converted. In all the affected areas they found were less than 2 meters in elevation. So very, very low elevation. And if you're interested in looking further, there was a historical analysis done by Matt Kirwan, who is down at Virginia Institute of Marine Science. And he found that over the last 150 years, 20,000 acres of farmland, I think that is along the entire East Coast, have actually turned into marsh. So just to give you some numbers, and these are numbers that I got from the Maryland Department of Natural Resources. So the North Carolina Department of Natural Resources may have similar numbers, but we found that, or they found that in Somerset County, 3,000 acres of ag land will convert to wetlands by 2050. And just to put that in reference, that's 8.5% of the ag land in that county. And in Dorchester County, which is the county right above it, that's 11,600 acres. And by 2050, and again, that's 12.5%. So that's just to give you a sense of the magnitude of the problem. It is a small amount of the total agricultural land, but it disproportionately affects farmers that are working in those areas and disproportionately affects their land, of course. So Steve showed that really great transect of the different salinity stages. So I thought it was cool that I had a similar figure, just to a transect of what a field looks like that's undergoing saltwater intrusion. So you can see I have on the left-hand side, the healthy crops illustrated. And then on the right-hand side is where the field meets the tidal creek or the marsh or even open water. And you can see there's this sort of transition zone where marsh plants are creeping in onto the ag fields. There's kind of this bare area where yield has declined, so no crops will grow. And then soil in underneath the layer of aerated agricultural soil slowly becomes waterlogged, becomes saline through the movement of groundwater, but then you also get salinity pulses from high tides or storms, kind of these overtopping events where salinity is coming to the soil from above. So the question is, how do we manage these areas? I'll just show you some pictures of what that looks like on the field. So I went out on a farm field one day. It was a spring high tide, and this was a field that was actually in production the year before, but had to be taken out of production because of things like this. They tried to plant crops and the seeds wouldn't germinate because the field was completely flooded and the seeds all washed away. And you might think, okay, maybe this is fresh water from spring rains, but the salinity was actually 6 parts per thousand, which is much too high for a lot of crops to grow. Some more examples on the field. So here's a soy field where I measured the soil pore water salinity to be 10 parts per thousand. One of those ghost forests I was talking about, salinity here was about 10 parts per thousand. And then you have this really interesting thing on the right-hand side here, which is that the soil pore water actually became hypersaline. And that's because we were in a period of heavy drought during a very hot summer. And so because of evapotranspiration, a lot of the salts actually moved up through the soil crust and precipitated on the soil surface and sort of formed these hypersaline environments, even though the incoming water was of a much lower salinity. So that's something really interesting to think about when you're managing land, these pulses of drought and rain and how they may be changing with climate change. Just another example of one of those plots and some aerial imagery of what one of those sites looks like up close. Again, I told you I'd show you more drone footage. So this is just one approach we're taking, is we have had these salt tolerant crop trials in, I guess this is the 3rd year of the project. So we're testing out, I don't know if you guys can read this because it's a little small, but we're testing out these different crops and seeing how well they might do along these transitional zones. So we're looking at things like salt marsh hay, which is actually a native wetland plant, but also has commercial value. These salt tolerant soybeans, switchgrass, which is a very, very tall grass with a deep rooting system that's really great for soil remediation. Sorghum, which has a natural salt tolerance, and barley, which also has a natural salt tolerance. We're sort of rotating these crops throughout throughout different sites all over the Eastern Shore, and we're seeing how well they do. And just throughout this whole process, we just really value the input of people that are on the ground every day, working on the land, telling us what their needs are, telling us what specific issues they're facing, and helping direct our research to help figure out how we can adapt to this problem. Thanks. So I think that's all my slides. If you have any, I know we're going to answer questions during this panel, but if you have any really specific questions, here's my contact information down at the bottom. Thank you.
Thanks, Dani. Our last panelist, Rubén, I think will be able to answer or help us address one of the great questions that have already been shared in regards, kind of where do we stand with plant development, genomic advancements that will enable crops to be more resilient to wetter and saltier conditions. So Rubén, let's.
Thank you, Kathy, and thank you, Dani and Steve, for the 2 previous presentations. I decided to go without slides. I think everyone is a little bit tired of seeing so many slides, particularly at the end of the day. So I'll just try to give a brief introduction of why actually plants are not big fans of salt. And then, as Kathy said, I'll comment a little bit on possible avenues to develop more salt tolerant plants. So as you have seen, particularly in the slides that Dani has shown, plants are not big fans of salt. And they are not big fans of salt for the same reasons that we as animals are not big fans of salt. And it all comes down to maintaining ionic homeostasis inside the cells. So we have certain concentrations of ions in our cells that allow physiological and molecular processes to work as they should. And then when we have these events of salt introgression, salt is sodium chloride, right? And we have these particularly sodium, high levels of sodium that start to enter inside the cell, and that alters the ionic homeostasis of the cell. So most of the plants are not able to deal with those super high levels of salinity that Dani and Steve were showing, particularly closer to the sea. Only a few species, marsh species, can deal with those 25 decisiemens of conductivity in the water. So most of the plants will try to avoid salinity, and there are some really cool works showing how roots, as they grow, if they get in touch with a particular high salinity patch of soil, they will try to avoid that patch of soil. That's not really a solution. If you have a hurricane event, there's no way to escape. Plants do not have legs, so they have to deal with that. A lot of the species will not be able to deal with it, and then they will just die. But then there are certain species, and then within one species there is also variation in terms of salinity tolerance. And there are two main strategies of salinity tolerance. One of them is exclusion, mainly sodium exclusion, and that can happen at the root level, so trying to avoid sodium to enter the root. But then it also can happen in the shoot level. So what a plant does when it's in the root, when it's exposed to high salinity levels, you have high concentrations of sodium and getting into the cell. The plant cell tries to maintain that ionic homeostasis. So one of the things that it does is to pump protons outside of the cell to try to maintain that ionic balance. Energetically, that's expensive, because think about a pump, and that pump needs to be wired to the ATP production of a plant cell to pump those protons outside, right? So that's costly. If sodium gets inside the root and then is transported to the shoot, following the stream of water through the xylem, there are pumps that what they do is in the leaves, they try to pump back into the xylem these sodium ions, and then that sodium might be exuded through different strategies in the leaves. So there is a well-known sodium transporter that has been identified in Arabidopsis, but also in other species such as wheat. The name of this transporter is HKT. That does exactly that. It pumps sodium from the leaves back into the xylem sap. So on a way, the genetic architecture of salinity, so that's sodium exclusion, sorry. Another approach is to basically increase the osmotic and tissue tolerance of that high concentration of sodium in the cell. The first strategy has a relatively simple genetic architecture, and through a study, through genome-wide association studies, both in mobile species such as Arabidopsis and in wheat, again, people have been able to identify this transporter, and that's promising for possible biotechnological approaches, right? Because simple genetic architectures are more amenable for transgenic approaches, where you could maybe overexpress the gene that codes for a transporter that basically is pumping out sodium from the leaves into the xylem cell. So that's one strategy that would make use of biotechnological approaches. Another strategy deals more with introgressing varieties that, because they have adapted through many years to soils with increased soil salinity, they have developed a number of different strategies to deal with these high levels of salinity. And then you can take those varieties and using traditional breeding methods, introgress those possible beneficial alleles from those varieties that have adapted to those soils with high salinity into higher yielding varieties that might be more salinity sensitive. And I guess that with that, I'll stop, and we'll be happy to take questions now from the audience.
Yeah, thanks, Rubén. So, gosh, thanks to all three of you for giving us a lot of material across a wide range of scales to try and piece together to better understand the impacts and the opportunities to mitigate those impacts. I want to take it back a step, and it seems like there's two dimensions that we need to think about in terms of managing or thinking about impacts to agricultural areas. So one is the increase in salinity, and two, changes in the hydro period, right? So the timing, the frequency, the duration, the magnitude of flooding. And I just, maybe Dani or Steve can help us untangle those two pieces and understand, does one have more of an impact, and where salinity changes versus changes in the hydrodynamics might play a role in affecting plant production or crop production?
Dani, you're welcome to take that if you want, otherwise I can.
Yeah, sure. So I was actually just busy answering a question that had appeared in the chat that was kind of related to that. So we are seeing starting to see some of these sort of feedback loops. So when you have an area that is experiencing severe crop decline, you end up with these bare patches on the landscape. So you're exposing a lot of this just bare soil, especially during the summertime when it's very hot out, to a lot of evapotranspiration. So it's pulling more salt up through the soil, and it's making those conditions in the upper soil crust even more saline, hence making it even harder for crops to grow. Whereas there are, and someone had mentioned this to me in the questions, there are actually some crops that can be planted that have sort of remediative properties. So for example, switchgrass is a good one. It has a very deep rooting system. So it helps to provide these channels for salinity to actually, or salt water to actually leach through the soil with rain. It helps with soil aggregation. It helps soils create more organic matter, and it provides just a physical cover for the soil, protecting it from higher rates of evapotranspiration. So some crops can actually reduce salinity concentrations in the soil. And of course, this only lasts for so long. This depends on how extreme your saltwater intrusion is, and it depends on how frequently the area is becoming flooded, because if it's constantly being bombarded by high salinity, maybe tides, then maybe that that crop isn't going to work as well there.
Yeah, another aspect of that is actually, the preconditions before the salinity event occurs. I was on a call yesterday with NASA. We're looking at possibilities of using remote sensing to better predict where these episodic salinity events are coming from storm events. And, one of the big challenges is that NASA will say, well, we can tell you what areas are inundated by water, because that's a really strong signature. But the challenge of that is that if you have soil that is saturated with water, with fresh water before an event occurs, and then you have the saline water coming on top of that, that water can come in and actually go back and have much less effect than if you have a very dry soil and that overwash comes on, if that storm surge comes in. So it's a bit of a challenge as to how you would use remote sensing with this. But, if we had a better idea of what the soil moisture was before a salinity event and then the salinity event occurred, that difference might give us some indication as to what vegetation and how extensive that vegetation damage could be. But it's a really difficult situation, particularly, with climate change, because what we're seeing more of these drought events occur in the Southeast now. So if you have a storm surge event, whether it's a king tide or something, in a droughty soil, that's going to have a huge impact. But if you have a hurricane, but the hurricane first dumps 5 inches of rain in a field, which is fresh water, of course, and then the storm surge comes in, it could have a much lower effect. So it's really complex interaction between vegetation, the soil condition before an event, and soil properties. It's this is not an easy problem to solve, which is part of the challenge of why it's so important to address it.
Yeah. You can see it from both angles, right? There's the drought when the water table is low, but also that sea level rising, preventing the freshwater discharge and just leading to more prolonged saturated conditions that make it more challenging to grow the crops.
Yeah, they have that problem now, on the coast of North Carolina at Mattamuskeet and the Pungo Wildlife Refuge. They have actually gates. I apologize for my clock. But they have gates there that they raise up to try to keep the storm surge from coming in during certain events. But that's when they raise those floodgates up and you have a lot of rain already inland, it floods with fresh water behind that. And so, you're damned if you do, literally, and damned if you don't. Because it's either you're flooded with fresh water or salt water. And then when you open them up, the gradient is becoming so small between those coastal areas and the sea level that the flooding is the water is taking forever to drain back out. It's, and people are really frustrated, as you can imagine.
So we've been thinking a lot about, in our conversation today, about the interaction of that salt front, if you will, and the freshwater front, the terrestrial freshwater front and the sea level saltwater front, and how that can change the salinity and the flooding in our ag areas. How does one of our audience, a member of our audience, pointed out that there's a lot of development going on in the coastal areas and a lot of changes to surface topography, a lot of impacts from long-term land management strategies, ditching, berms, roadbed. How does that factor in or compare those kind of impacts compare to what's happening because of climate change?
So I know that you saw the image I shared in my slides with all the different drivers of saltwater intrusion. And so one of the biggest issues with overdevelopment is all the water diversion that happens. So you get fresh water pulled off for a reservoir here or for irrigation, agricultural irrigation or something. And then by the time it gets to its source at the estuary or the ocean, it's trickled to a small amount. So that really changes the salinity dynamics. So if you have a farm along a tidal creek, and it's not getting as much freshwater input, as much freshwater delivery because of that development and that water diversion, then your effects of saltwater intrusion can be exacerbated. And that's just one major example that I can think of.
Great. Steve, have you seen any evidence in your work of kind of the results of shoreline hardening or development topographic changes that alter the interaction of these fresh and saltwater sources?
Well, some of this goes way back. I mean, they've been developing drainages in the coastal areas of North Carolina since literally Washington. I think when they were doing some of that way back when, and then back in the 40s and 50s, they did even more, particularly for plantations. And as Dani mentioned, these channels and canals can bring the salt water much farther inland than it normally would go. Which is a problem. But right now, the Army Corps of Engineers has I think it's a $15 million project that's been going on for 2 or 3 years now that's looking at hardened structures and what can be done with that. And again, I mean, everything, it's redundant to say, but everything's very complicated. What can keep salt water out of one area then can funnel it into another. And so, this is an issue that it's a civil engineering issue. It's a social issue. A lot of these areas that we have problems with in the Carolinas in particular are not, it's not even a function that that the soils are the problem. It's getting housing in there. So they'll have these floods that come in, and there may be structures that have been put in place to protect the fields. But if they damage the structures where people live, then the people can't live there. If you can't live there, you can't work the field. So, it's a matter of not only just worrying about the fields, it's a matter of worrying about the people and the economies and the social structure. It's an extremely complex issue. And there is, unfortunately, no easy answer. And of course, all the projections of sea level rise, as Dani showed, are just that this has only become worse. So, the question at some point becomes, where do you draw the line? At one point, does it not become economically viable to continue to protect some of these areas? So how much structure can you put in? How high can you make the dikes and the levees and the floodgates? And, and then at what point can you no longer afford to do that? I mean, we're seeing, parts of that already on the coast of the Outer Banks of North Carolina, where we have this continuous loss of Highway 12, which is the road system that runs all along the Outer Banks there. And it's constantly, multiple times a year, parts of it being washed out, in communities like Rodanthe and Waves and those areas are being washed out. And so it's not just an agricultural issue, but it's a whole structural and economic, social issue.
The next question I'm going to direct to Rubén. And Rubén, I'm thinking of Steve's slide where he has the zones of salinity zones and relates kind of the agricultural potential to those salinity zones. And can you help us think through what is the potential to kind of shift or modify or crops to those zones? How much leeway, if you will, do we have to expand the potential for these crops to withstand high salinities and the wetter conditions?
Yeah, I would say somewhat limited. To be honest with you, in these areas where you have these frequent events of introgression due to high tides, due to hurricanes, etc., I personally think that the best approach is to do something like what Dani was showing, trying to introduce species such as switchgrass, etc., that are much better adapted to those type of conditions. You can only do so much, right? With either biotechnological approaches. There are around 100 genes that have been described in the literature, most of them in model species such as Arabidopsis, that either through overexpression or underexpression have a positive effect either in processes related with increasing the osmotic tolerance or increasing exclusion processes, but also dealing with the effects of salinity stress, like more oxidative stress, etc. But again, you can only do so much, particularly for species like corn that requires so much water. Remember that the more water that you are going to pump through the plant, the more salt are you going to be acquiring. So for that transition zone where you might see a decline on productivity on a species like corn, but the soil might still be amenable for some agriculture, either something like switchgrass, or people will say sorghum, which is a better version of corn, would be the solution, rather than trying to invest too much energy into a biotechnological package that might be too expensive to deploy and really not really worth it. In our lab, we are definitely interested on this idea of adapting and introgressing corn tolerant varieties that, because they have been evolving in areas that are close to the coast, have developed a higher salinity tolerance at the expense of a yield component.
Thanks, Rubin. That was helpful. I want to go back to a detail that Dani mentioned, and I don't know that we really gave enough attention to. I think I heard that the increased frequency of saltwater intrusion is likely to affect nutrient dynamics. Can you say a little bit more about that effect and the significance of that?
Yeah, absolutely. So there's a lot of great work on this actually coming out of North Carolina, and actually coming out of our lab too, and it's showing that the saltwater intrusion can actually cause the release of legacy nutrients, particularly phosphorus and nitrogen, that are stored in ag soils into nearby waterways. So there's some researchers at Duke who showed that basically ionic exchange, so sodium coming in from salt water, tends to bump ammonium. So that's a form of inorganic nitrogen, tends to bump ammonium off of soil particles. So a lot of fertilizer is applied as ammonium or becomes reduced from nitrate fertilizer. So this can cause really localized water quality issues and also cause those nutrients to be lost from the field. So they're going into the water instead of being taken up into the crops. Same thing with phosphorus. So it's actually the sulfate component of seawater. So seawater delivers a lot of sulfate to the soil, and interactions between how that sulfate interacts with iron that's bound to different forms of phosphorus in the soil, essentially under reducing conditions. So when soils become waterlogged, they become reducing, they become depleted in oxygen. That phosphorus can be bumped off of iron complexes and released into waterways where it's bioavailable, where it can also cause pollution issues. So there's study after study showing this is happening in freshwater wetlands that are becoming salinized, in salt marshes that are becoming more saline, and there's a lot of new work showing it in agricultural areas. So these transitional zones could really be hotspots for management of nutrient pollution, really hotspots for developing conservation when they become too waterlogged or too saline to farm anymore.
So is it the salinity, or is there other kind of properties of seawater that are affecting the nutrient dynamics?
Yeah, so in short, it's really two things. It's the actual ions that make up the saltwater. So your sodium, your calcium, your potassium, sulfate. So it's all those different ions that are interacting with nutrients in the soil that are generally leading to that nutrient release. And then it's also the fact that the soils are now going from being well drained to becoming frequently inundated if they're in an area that's that far along its path of saltwater intrusion. So those inundated conditions change oxygen levels, and that completely changes the chemical cycling of the soil.
Yeah. And that could have effects on heavy metals as well, right? Like mercury.
Yeah, so there's, I just listened to a really interesting talk last week. There's someone who's researching arsenic in rice because rice paddies are flooded for weed control because rice is flood resistant, unlike a lot of other crops. However, when arsenic gets reduced under those waterlogged conditions, it changes to its elemental form, which is can be taken up by the plants. So if you've ever seen warnings about arsenic in rice in areas that are undergoing, for instance, saltwater intrusion, those heavy metals could also be potentially mobilized.
So Danny, if I can interject a question, Kathy. So Danny, so one of the options for that, if you had a soil, for example, that looked like it was tending toward the end of its productive cycle, it's becoming increasingly saline. Would one option for that, one remediation or partial remediation, be to use a highly salt tolerant crop in there to try, but not fertilize it, to try to pull out as much of that nutrient as you can before it kind of converted over? Would that possibly be an option?
Yeah, so that's a really good question. So that's exactly what we're doing with those salt tolerant crop trials that I showed you that schematic of. So we've got like barley in there, which I think has and someone can correct me if I'm wrong, but I think barley is can be up to 8 parts per thousand salt tolerance. Sorghum's pretty salt tolerant too, maybe 6 parts per thousand. So we're looking at these transitional crops that maybe aren't like the highest payout cash crop, but can maybe generate some sort of profit margin for the farmer who's trying to work those areas and also take up excess nutrients before the land slowly transitions to a point where it's just no longer viable to farm there. So we're looking at that. We're in the 3rd year of this 5-year study of that, and we're getting pretty good yield results from I can just tell you anecdotally, from our sorghum's doing pretty well, and a lot of farmers that are dealing with saltwater intrusion on the Eastern Shore have already switched to farming sorghum in those areas. And then we are also looking at switchgrass, which does pretty well in these areas. And one interesting thing about switchgrass is that it could help the land transition to a conservation easement because it's a native perennial grass. So if that land is eventually taken out of farming, you already have that native perennial grass established, and it's already going to provide those ecosystem benefits. And I believe that it's already included in a lot of practice codes for the Conservation Reserve Program to plant switchgrass in certain areas.
So I know, gosh, we're coming near to the end of our session, I think, right? It's 5:15. Is that right, Michelle? Am I remembering?
Yes, but we're doing well right now and keeping up with the questions. So please feel free to continue.
Great, because we do have another question. Some of us are still thinking about the potential for plant breeding to help us manage or mitigate losses to farmers in coastal lowland areas. And great question, thinking back to Steve's slide, showing that asparagus has a much higher tolerance to salt than other crop plants. And so is it possible that we can transfer or capacity from asparagus to other crops to increase growth potential in saltier, wetter conditions?
You know, I guess there's two parts to that question. One is, can we do it? And the other one is, should we do it from a farming perspective? You know, biologically, you can grow a lot of things, but you have to have a market for those commodities. So, you know, it's, you know, unless the Asparagus Marketing Board got on board with this, and U.S. asparagus consumption went up by 5,000% or something. There's a limited capacity of how much asparagus you can grow and market in these, and all the other crops as well. In the manual that I was alluding to previously, and I should note that Chris Miller, who's on this call, and Nancy Gibson are on this call. They're both co-authors on that, and Nancy's actually the lead author on that manual. We talk about different commodities in that and what the options are, and there's actually, we have an economist in there as well. And they discuss, where is that break point? So at what point can you still get a crop off this, but for every acre you plant, you're losing X dollars to plant that and to harvest that and to harvest that particular crop. So yeah, there are certainly different crops that are, and we've talked about them, and I think there's a question in the chat box, which I don't know the answer to, as far as salt tolerant soybeans and corn, and I know that some are more than others. I don't know about the development of those particular cultivars, but certainly there is a wide range in there, and it's a matter of working with your extension agent and other folks that are knowledgeable about what the market rates are for these different crops, and then testing your soil and seeing where you fall within the salinity values. And between the two of those, like any other farming practice, you need to make that decision, what's right for you. And at what point do you say, nope, we can still get a crop off of this particular piece of land, but it doesn't make economic sense for us to do so. And then you think about conservation reserve programs and those sorts of options.
Do you know of, speaking of economic impacts, thinking through the loss of ag lands to sea level rise and also development, right? So we're losing extensive areas of cropland. And what is the trade-off or the impact on our capacity to sustain food supplies? I don't know if any of us have that information to.
Well, I mean, that's why our group was created, the USDA Southeast Climate Hub. That was a direct concern from President Obama and then the current secretary at the time, that we have as a nation, we have certain requirements for food and fiber, and then the world also depends on us and our ability to produce that as well. And there is a real concern that not only because of salinization, of course, but drought and all the other disturbances which are increasing, that we may have limited capacity to continue to do that, both as a nation and then individually as communities and as individual producers. And so that's something that hopefully the current administration has accepted, and the next administration, I think there's a lot of cautious optimism that there'll be a big increase in that type of research and that type of development, that we're really reaching this sort of critical threshold where if we don't do something very directed and substantial to make sure that we have these sustainable agricultural systems and forestry systems, that we're going to all of a sudden have these events that are going to really put us in a place that we've never been before, or at least maybe since the Dust Bowl days, where we have that level of disturbance. And of course, we're already seeing that out west with the fires, but the sea level rise and salinization is an example, relatively locally, of that same kind of disturbance.
How does the work we're doing on the East Coast and the impacts that we're seeing in our own neighborhoods compare to what's happening around the world? How do those pieces, can you help us put those pieces together?
Yeah, so I can talk a little bit about that. So there's certain geographic issues that are very specific to the East Coast, like we're on the coastal plain. It's sort of this gently sloping landscape versus, you know, there is some saltwater intrusion, say on the west coast of the US, but it's, I would say, relatively less of a problem for agricultural production just because the landscape tends to be rockier, and so there's not as much saltwater infiltration. However, there are areas around the world that have maybe similar geography to us or facing the same problems. So one example I can think of is the Netherlands, which is actually very large parts of it are actually now below sea level, but there's just been so much engineering in that country to increase, to keep crop production going, that they've managed to keep saltwater out. But it's taken millions, probably billions of dollars in engineering. So maybe that works for a country of that size and scale, but that may not be a viable option for a country like the US, which is much larger, and there's just not that money to put towards that infrastructure, say on the Lower Eastern Shore or the Carolina coast. There's some interesting genetics research coming out of the Netherlands. They did work growing potatoes underwater in brackish water conditions. And so there's this one farm that grows what they call salty potatoes. So they've been, I think, pioneers in that genetics research. That's been really interesting. But yeah, just in a nutshell, these are global problems. These aren't just isolated to our states or even North America.
And you touched on that a little bit, right, with the reference to the rice paddies, the impact that sea level rise is having.
Yeah, so I imagine there's areas where, so I don't think rice, and correct me if I'm wrong, but I don't think rice is a very salt tolerant crop. So probably in a lot of low-lying islands where a lot of rice is grown as like the main cash crop, I could see there being a lot of issues with crop production in those areas.
Yeah. What do you see as kind of the critical information gaps, or kind of next steps or research opportunities that we really need to tackle in order to mitigate or manage the impacts of sea level rise?
So one of the things that we have a lot of colleagues working on is just mapping which areas are going to be the most vulnerable. And so figuring out maybe, okay, these upland areas are experiencing a little bit of saltwater intrusion. Maybe these are spots where we should strategize trying to remediate the soil by growing certain crops or flushing the soil with fresh water, something like that. But mapping other areas and saying, okay, these areas are really vulnerable. Is it worth the investment to try to grow crops there? Or these areas that we want to target for maybe conservation reserve or another easement strategy? So I think mapping is one of the most important things.
Steve, you want to build on that?
Yeah, as I mentioned earlier, we had a discussion with NASA the other day. They're trying to do a collaboration between USD and NASA. And long-term monitoring is really the key for this. I mean, it's with climate change in general. Climate change itself is not the worst problem. The problem is the variability of climate change and the rapidity of climate change. If we had 1,000 years to deal with this, we could adjust to it really easily. But when it's happening in years, literally at this point, and the variability is increasing in years, that's the problem. And so to the extent that we can better monitor what's going on and then develop algorithms that will, both for sea level rise and also for these episodic storm events, then that allows us to be better predictive of what we can do on the landscape. So understanding is half the battle. And once you understand it, then you can develop different protocols and processes to address it. But until we decide that this is an issue, this is something we really need to address as a nation, we need to put the types of funding into it that will allow us to address this as a nation, it's only going to get worse. And the climate change, CO2 is a long-lived gas. It's going to be around for the next century or so of whatever we do, but we can have a big impact on what that trajectory looks like moving forward over the next 100 years, is where it starts to taper down or doesn't. and then what we do before we get back to a point that we can be sustainable again. But right now, we're on a trajectory that is not sustainable, whether it's the sea level rise issues or productivity in general.
Maybe just to add on what Steve was saying, from a breeding perspective, it is very difficult to breed for variability, right? So you might develop a salt tolerant variety, but then you may put it in into a place where you may not see a hurricane event in 10 years. So if what you have bred for as a trade-off in non-stressful conditions, it's complicated.
Yeah. Rubin, what opportunities or research or information gaps do you think about and see as kind of critical next steps or opportunities for technology development?
Again, I just want to mention what I just talked about. This problem with the variability of these events is complicated. So in general, if somebody asks me again, I would just recommend to, rather than invest in a highly costly biotechnological package to develop more corn salt resistant varieties, to switch to other species that might even help to maintain as a barrier for this salt introgression and keep some of the land areas that are a little bit more inside still highly productive. It's always better to grow something than just to leave the land bare, because that also has an effect on soil leaching, etc. So a lot of times you just have to try to contain these very dramatic events of introgression with something that might not yield as much as you want, or might not give you as much income as you would like, but it keeps you going there.
Yeah. Well, I see we're coming to the bottom of the hour, and I just want to thank our panelists, Steve McNulty, Dani Wiseman, and Rubén Rellán-Álvarez, for a great conversation and helping us think about the impacts from sea level rise to agriculture, but also on our coastal ecosystems more generally. These are areas where a lot of development is concentrated. So there's potential impacts not just to agriculture, but to our front lawns and parks systems. So thank you for helping us think those through.
Yes, and Kathy, we want to thank you as well. You did a wonderful job moderating this, and thank you all for sharing your time and your knowledge with us. We really appreciate you helping us wrap up the end of 2020. Even though it's been a crazy year, we're glad to end on such an awesome note with you all. So we look forward to seeing everybody in 2021. Please have a happy holiday. Thank you to our panelists, Kathy, and thank you to our sponsors, and we'll see you next year.
Thank you, Paul and Michelle, for providing this opportunity.
Thanks, guys.
Bye.